All right, party people. Here we are again, GM. Most of you know us by now. I'm Ellison, the founder of Crack Labs. You got Austin, the co-founder and CTO here. We have Ben joining us from the Axelar Foundation, kicking this off. So let's bring Ben on in. Ben, how's it going?
Hey guys, good to be here.
Nice. So here you've got we're excited to have you as always. Would expect that we'll see people continue to trickle in, and know you have a banger of a presentation for us today on powering the interop future with Axelar. So before we dive in, anything that you want to cover for the audience?
No, just really excited to be here and to get this show on the road. Today's talk is going to be, I'll outline it as I start, but it's going to be more overview, how we got here, where we're going, what's unique about Axelar, and have a good chance to take questions from the audience.
Nice. Well, before we dive in, let's just make sure that the slides are looking good. Austin, I'm going to pull you off and myself off. Beautiful. Looks like it's good to go. So with that, we'll...
Nice.
Yep.
Awesome. Cool. Yeah, I can take it away if we want. Yeah, hey guys. Thanks again for tuning in today. Today's talk, hopefully we shouldn't take up the full time. I'm just going to try to keep it a bit more high level, get everyone excited for the next few weeks by working with Axelar. So today we're going to go over like the need for Interchain, how we got here, where the space is going, the problem with pairwise bridges as it existed over the past few years. From there, we're going to get into Axelar, a brief overview of Axelar, how it's unique, what are the advantages of working with Axelar. I'm going to wrap up with a talk about our amplifier service. I'm not sure how many people are familiar with it. It's some pretty cool stuff. And then we'll go into a preview for next week and then Q&A with whatever time we have available. I want to try to keep this as informal as possible. So if you guys have any questions, I'm going to monitor the comments here pretty closely. Just cut me off with a question. I'll try to answer this as quickly as I can. And of course, if anything comes up after the fact, I'll be monitoring the Telegram channel for pretty closely for questions. Yeah, so a bit about myself. I got into the blockchain space back in 2017. I'm based out of Toronto, Canada. I've been with the Interop Labs team for 2 years. And back when I was getting into the space, these were some of the major players at the time in blockchain. There was, of course, Bitcoin at the time, but we'll ignore that one for now. But there was, of course, Ethereum was kind of like the blue chip project for anything smart contract related. But it wasn't just Ethereum at the time, as it's not today. There were projects like Neo, which people were calling like the Chinese version of Ethereum. That the people were saying that was growing there like crazy. There was IOTA, there was EOS. People were kind of calling that like Ethereum on steroids at the time. There was Tron, of course, which is still around today. And the mindset that a lot of people had, and you go to like meetups and stuff, you're trying to crack the space, is like, oh yeah, Neo's going to be like the Ethereum killer. No, like EOS is like way better than Ethereum, or Ethereum's going to be the winner. It's going to be the one chain to rule them all. And the term that kind of emerged was this idea of chain maximalism, whether it's Ethereum or not, or one of those other chains. Which chain will be the one to rule them all? And then we still saw that over time a bit with like the rise of Solana and Binance. But I think it's safe to say now in 2025, looking back all these years later, is that chain maximalism is completely wrong. None of this ever happened. And by none of this, I mean, there was never one chain to rule them all. Even Ethereum. Ethereum didn't go and kill all of its competitors. There are still many other blockchains in existence. And I can prove that right here by looking at this slide. I'm not sure if it'll let me play the video here. It doesn't look like it will. But if what this is meant to be is, if you look at a website called chainlist.org, I have done a brief screen recording here. And chainlist.org will basically show you a list of all the different blockchains that exist. Let me see if I can actually, that's fine. But if you go to chainlist.org and scroll down, you'll see that there's thousands and thousands of blockchains that exist today. And it's not even all the blockchains that exist, because it's impossible to really know for certain how many blockchains do exist. And nowadays, with all these new tools, it's easier than ever to build blockchains than before, especially compared to like the early days of blockchain. So this idea that there's going to be like one chain to rule them all now, I think is pretty silly. And this is not anything controversial that I'm saying, right? We've known this for a while, pre-Axelar even. We saw the rise of these like bridges. And a lot of these bridges were like more centralized, like kind of multi-sigs. And that was, you know, some of these bridges worked, but they were tremendously sacrificial on the security front. And we saw the issues of that. These are some headlines that I cherry-picked regarding some of the more famous hacks that happened on bridges. Some of you guys may remember whoever was in like the Axie Infinity gaming space, like when the Ronin network bridge got hacked for like over $500 million. The Harmony bridge that happened for $100 million. And I could probably make a collage of it on this slide if I really wanted to. Just all like the kind of tragic bridge hacks that happened, which really paint just a terrible light on our industry as a whole. You know, if people are hearing about all these different things in crypto getting hacked, even if it's not blockchain, from the outside world, it's a really bad look on the space. And an interesting article here by Chain Analysis that came out a while ago. I want to point to the top right here on the first line. They estimated that $2 billion in 2022 alone, which is about 70% of all funds stolen in crypto in the entire industry, were attacks on these centralized bridges. So if I pause right here, let's backtrack. We know that chain maximalism is wrong. We know that we need to have a multi-chain world. But at the same time, as an industry, we have a lot of work to do with how we conduct cross-chain interoperability in the space. And that's kind of what gave birth to Axelar. That was the thinking at the time when the protocol was launched, and why Axelar came to be. So what is it? In its simplest form, if I had to really sum it up into a sentence, is Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. Now, that's a lot of jargon and a bit of a loaded sentence, but it is accurate. And we're probably going to spend the rest of this talk, I think, dissecting this. And again, our future talks will have more open code, actually building stuff together, but I think it's really, really important to understand the fundamentals of how we got here, why Axelar is important, why Axelar is different, before we actually start building cool stuff on it. So there's two major improvements that come out of the box when you're building with Axelar compared to more traditional interop solutions. And that is scalability improvements as well as security improvements. So let's start with scalability. This is probably the easiest way to visualize Axelar. Remember, it's a blockchain that connects blockchains, from my previous sentence. It implements a hub and spoke model. What does that mean? It means that all these different chains on the outer ring here that want to connect to each other basically connect to Axelar. And then from there, through their connection to Axelar, they can connect to other chains. So as opposed to, like, let's say Polygon and Avalanche here on the top of the slide, Polygon and Avalanche never actually talk directly to each other. They talk to Axelar, and by extension, they talk to each other. Now, why does this matter? Why is this such a big deal? And that is for this first reason, for scalability improvements. Imagine we had a scenario where we didn't have a hub and spoke model. Rather, we had pairwise bridges where Polygon spoke to Avalanche and Polygon spoke to Ethereum and Phantom spoke to Avalanche. Let's actually look at this little demo I have here. Sorry, I apologize for the border here, but imagine we have three chains: Ethereum, Binance, and Polygon. Each of those chains want to talk to each other. For those three chains, that'll be 6 bridges. You can just count the arrows here. Now, let's say we want to add just one more blockchain to connect each of those chains to each other. Let's say Avalanche. That number now shoots up to, what is that, to 12 bridges. Now, imagine a world where we have 100,000 blockchains that we're connecting. That's kind of the attitude we have to have towards this. The number of bridges just won't scale. for each new chain that we have to add, it just won't work with the amount of bridges that we have. And we see this with other interop solutions as a huge issue, right? There are certain interop solutions out there, I'm not going to name call, but who basically claim that they connect, let's say, 30 chains. But even though they maybe work with 30 chains, it doesn't actually mean that they connect each of those 30 chains to each other. For example, Ethereum might go to Binance, but Ethereum doesn't go to Polygon. To go to Polygon, you have to go through Avalanche. And that is an issue that we don't have when we go with the hub and spoke model. All you have to do is plug into Axelar, and once you're plugged into Axelar, you're immediately connected to any of the other chains that Axelar connects. And imagine a world with like 1,000 or 100,000 blockchains, that's going to scale a lot better. So that's scalability improvements. If I go to the next point of security improvements, we have to focus on this first line here. Axelar is a blockchain that connects blockchains. Remember what a lot of what I said before for the bridges that were getting hacked and the $2 billion worth of funds that were stolen in 2022 came back to a lot of these bridges being like multi-sigs. Axelar, on the other hand, is a blockchain for blockchains. What does that mean? Well, it is a blockchain that was built using the Cosmos SDK. It is running a proof-of-stake consensus mechanism with currently 75 validators. Anyone here who might be familiar with the Cosmos ecosystem, these team names might be familiar to you. These are some of the validators who are currently working with Axelar. So Informal Systems, Pokachu, P2P.org. These are very well-known validators in the Cosmos ecosystem. They're not just made by us. They work with many of the blue chip Cosmos projects beyond just Axelar. But having said that, these are not people who we really cherry pick ourselves. It's an open protocol, meaning that if you want to be a validator tomorrow, you can accumulate some AXL, stake more than the 75th lowest validator, and you will be one of the 75 validators. It's permissions. Like anyone can be a validator if they choose to. And having an actual blockchain secure the interop layer of Web3 is a tremendous step up than having just a 2 or 4 multi-sig. In fact, if you think about it, it makes sense, right? We're all in this industry to work with blockchains, so we may as well have a blockchain also secure the interop layer of Web3. And don't just take my word for it regarding the security of Axelar being top-notch. This is a report. I left the QR code up top if any of you guys want to scan it and take a look at it for yourself. It's a really good read. It's basically a bridge assessment report that the Uniswap guys put together. And they are basically looking to work with an interop provider, and they did like a comprehensive review of every interop service in Web3. And Axelar was one of 2 services that were greenlit by them to proceed. The other one was Wormhole, who also has like a pretty similar security model test, being like a Cosmos chain with I think like 19 or 20 of their guardians, they call it. Just like how we have like the 75 validators. So it's a really good read if anyone wants to take a look at the bridge assessment report from Uniswap. And let me share my screen here. I want to show off some of this validator-based security because, like I said before, we do have these validators who are doing like traditional work of a validator, right? Like creating new blocks for the Axelar layer 1. But with Axelar, we expect our validators to do a bit more than just append new blocks to our chain. Let me see. Can I present here? Share screen. Let's do entire screen. I hope, can you see my screen? Just leave a comment if you can see it or if you cannot see it. I just want to share one thing. Let me remove this from the studio. Okay, I think you can all see now. I'm going to assume you are unless someone says otherwise. Yeah, okay. So if I look at this cross-chain transaction, don't really worry about what's going on here. This is an interchain transfer. Let me make it a bit bigger. This is an interchain transfer from Arbitrum to Base that happened earlier this morning. And then we're going to go through this in a lot more detail in future weeks. I just want to skip to step 3 of this interchain transfer. Specifically, the only step here that's actually happening, look at the little X here, that's happening on the Axelar layer 1 itself. So not on the Arbitrum source chain, not on the base destination chain, but on Axelar. If I click on this poll, you can actually see when it loads, all of our 75 validators that I was just talking about before actually coming to consensus. Basically, these validators are required to run nodes on the source chain, on Arbitrum in this case, and they'll basically come to consensus. Be like, hey, are you seeing this 0x56 transaction? I can click on it. It'll take me right to Arbiscan. Do you see this transaction that's happening on Arbitrum? If so, we vote yes. And you can see 91% of the validators here have voted yes. You can see all their votes here of the 75 different validators. And that is basically the security backbone of Axelar. It's these 75 validators coming to consensus about each message that was sent from the source chain to the destination chain. And the neat thing with Axelar Scan is it's all transparent. You can see everything happening here from the polling of the validators to, if I click on here, the actual transaction hash on the Axelar layer 1 itself, which I think is pretty awesome. Let me open my slides again, and I'll stop sharing my screen. Okay, sweet. So that is the security side of Axelar. And I'm going to go back to this sentence here. Again, what is Axelar is kind of, I guess, the key takeaway from this presentation. It's a blockchain that connects blockchains. I think we've covered that quite a bit. But this second line here, we haven't really covered. Enabling universal Web3 interoperability. What does that mean? Well, it means that we don't care about the consensus mechanism. We don't care about the virtual machine. Technically, with Amplifier, I won't even really care if it's a blockchain. You can connect as a spoke to the Axelar ecosystem. So look at these chains that I added here. This table is a bit out of date. We now connect a lot more blockchains than just this. You can see like the Ethereum, Phantom, Polygon. These are all chains from like the EVM ecosystem running proof of stake. We also have Osmosis. We have the Cosmos Hub. We have Secret Network, Injective. These are other chains from like the Cosmos ecosystem that connect, that we can also connect to Axelar. With Amplifier, what I want to touch on now, go back to this here. I'll go back to JMP after. With Amplifier, we now have the ability to connect any sort of chain that we want. So for example, Sweet, a Move-based chain. Stellar, a Rust-based chain. You can see actually a more updated table here of all the 81 chains that we're connecting now. And with Amplifier, we're able to integrate any of these chains onto Axelar. True universal Web3 interoperability. So how does this work? What do we actually do? Well, you may have seen something about like the Axelar virtual machine. And that's kind of the backbone that we use to build Amplifier. So remember, Axelar is itself a blockchain built on the Cosmos ecosystem. And what we did here was, pre-Amplifier, there wasn't really much going on the Axelar chain. We were basically just leveraging our validators, as I showed before, to come to consensus about messages that were being passed. But with Amplifier, what we did was enable CosmWasm on the Axelar chain. Now, what is CosmWasm, for those unfamiliar? It basically means the ability to actually deploy smart contracts onto a Cosmos chain. Basically, what that means is we can actually do a lot more stuff on the Axelar chain. And that is the technology that's kind of being used to integrate Amplifier. So on a high level, to integrate an Amplifier chain, don't really have to worry about it too much, but it allows you to, like, we can instantiate our contracts on the Axelar chain itself. We have to deploy contracts onto the external chain. So like our gateway contract, ITS, which I'll get to those in a bit, on the external chain. That's probably the hardest part of integrating a chain. For example, like Sui, when we wanted to integrate that chain, ITS and the gateway, they had to be completely rewritten from Solidity to move to deploy there. But for EVM chains, it's very straightforward. For example, Berachain, which we recently integrated, we could just redeploy our existing EVM contracts there. We then have to create a reward pool for our verifiers who need a kind of register their chain support there for each new chain that we're integrating. we have to then update a verifier set for that chain and register with what's called ITS Hub, which we don't really have to worry about for now. I'll save ITS Hub for another time. But these are the different steps here that are required to integrate a chain with Amplifier. Now, with COSM WASM being enabled, what is the benefit of that? Well, there are chains, for example, Ripple, which I haven't mentioned yet, can now be integrated. Ripple, for those who don't know, is a chain that doesn't actually enable any smart contract support. Like, it's very limited what you can do there compared to other chains with like Ethereum, where you can deploy contracts and use the EVM. With Ripple, it's a lot harder. So by actually having COSM WASM enabled on the Axelar blockchain itself, we can now integrate chains like Ripple. We can even integrate things that aren't chains. Like, imagine you have a Twilio application that you want to integrate as a spoke here, send a message to the Axelar chain, which now has logic built into it. And then from there, send a message to Ethereum. So I'll take a look at the questions here. I want to kind of wrap up with GMP, general message passing, which is kind of like the main use case of Axelar, which is now that we have this universal Web3 interoperability, we have a secure, scalable tool that we can use to connect chains. What can we actually do now that we're connecting chains? And that's kind of where a general message passing, or GMP, comes in. Let me just take a look at these questions here. Are we considering integrating base plus optimism chains? Yeah, like, the way I see it, I'm hoping that we're connecting like thousands of chains someday. We're at 81 last I checked. But yeah, true universal Web3 interoperability. I'm assuming like base and optimism chains, I'm assuming are more straightforward EVM connections. So it should be pretty straightforward to connect with Amplifier. There's no like need to rewrite any of our contracts in a different language. So yes, we want to. There's no chain that we want to purposely exclude, I guess is what I'll say. What is the validator threshold? How many validators need to validate and agree on the transaction? Great question. I don't have an exact number. I should. I can get back to you on that one. It should be in our docs if you want to get the exact number, but I'm hesitant to comment on the exact threshold that we need. But great question. Where was I? Yes, general message passing. So general message passing, or GMP, as you'll hear it commonly being referred, is basically, as the name suggests, the ability to send messages from chain A to chain B. So it could be something straightforward, like what we're seeing here. Like on Ethereum, sending a message to Avalanche, just a string like, hey, wag me, like, are we going to make it in this amazing, crazy space? But you can also send something a lot more robust, like a call to like safe mint 5 tokens, which, for the record, is what ITS does. ITS is not some new crazy consensus update that we have at the consensus layer. It is actually just a set of smart contracts that we built, leveraging GMP to do things like send messages to mint ERC20 tokens on the destination chain. But it's all under the hood using GMP. And what gets me so excited about GMP, general message passing, is that thought that, you know, traditionally it would be like, I have a smart contract on Ethereum, you have a smart contract on Ethereum, and we can now interact with each other because we're on the same network. GMP flips that on its head. It basically says, I am built on a blockchain that is connected to Axelar. You are built on another blockchain that is connected to Axelar, and we can now interact with our smart contracts as easily as if they were all built on the same chain, just by sending messages between each other. How it all works, that's a teaser for the next talk. We'll go very, very deep. We'll actually build a GMP application together. We'll go through the Axelar scan steps. We'll go through like a little diagram of how this all works. But another example of an application built using GMP, you guys might be familiar with it, is Squid. Squid, which kind of gives the pretty easy to use front end of like your traditional DEX. It's very, very powerful. You can send like in one click, like one ERC20 from one chain and receive a different ERC20 on another chain. But unlike DEXs, Squid is not a DEX. It's a router. It's not holding any, traditionally it hasn't been holding any liquidity, unlike, let's say, Uniswap or SushiSwap. Rather, what it does is it actually uses GMP to send messages between DEXs on different chains. So, for example, you have SushiSwap on Ethereum, Uniswap on Optimism. Let's just say I'm sending a message on the destination chain to, hey, when you receive this token, swap it for USDC and then give it to me on the destination chains. And for the user, it provides like that one-click experience, but under the hood, it's just sending messages to DEXs to actually give the token you don't want and receive the token that you do want. So that's another very powerful example of GMP in action in the wild. I think we covered Amplifier. And I think we have 5 minutes left. I'm going to briefly for next week. I hope this was helpful. The key takeaways I'd say is this slide here, this sentence, where Axelar is a blockchain that connects blockchains for universal Web3 interoperability. It doesn't matter the virtual machine, doesn't matter the consensus mechanism. We are able to connect that. And with GMP, you can actually send messages between those chains. For next week, as I said before, we're going to go much deeper into GMP. We're going to have a diagram showing exactly the step-by-step of how a message is sent. We're going to walk through code examples together. We're going to even go through like two-way GMP, so like send a message from Ethereum to Avalanche and then receive it back from Avalanche to Ethereum all in one transaction. It does it automatically like a kind of ping pong. And then we'll do a breakdown of the cross-chain transactions. I think I see one more question. Can we use Axelar to bypass the 7-day challenge period for optimistic rollups? Yeah, so right now when you're sending a cross-chain message, we do wait for finality on the source chain. This is for security, right? Imagine that you send a transaction from Ethereum to Base, let's say. Base is integrated from Ethereum to Base, but the transaction gets executed immediately on the Base, but hasn't finalized on Ethereum. Now you're in a bit of a pickle because there was a chain reorg on Ethereum, let's say. Now, for layer 2s, we don't wait for the 7-day dispute period for like the optimistic rollups. We wait for the transaction to just be finalized on the layer 1. So that takes about 30-25 minutes for layer 2s. Other layer 1s like Avalanche, Binance are way quicker, where the finality is super quick. And Cosmos chains are like instant finality, and the non-EVMs are really, really fast. So layer 2s are the slower one. It does not take 7 days. You can see on Axelar Scan a helpful statistic page of how long these transactions take. I'll show it for next week. But yeah. Does my application launch on the Axelar blockchain? No, your application does not need to launch on the Axelar blockchain. All what goes on the Axelar blockchain is like certain like amplifier connections. So if you're looking to connect the chain to Axelar, then yeah, you will need to instantiate some new contracts on the Axelar blockchain. But if all what you're doing is looking to connect like an ERC20 token from like Base to Arbitrum, you won't need to worry about actually building on Axelar. You will interact with our edge contracts on Base and on Arbitrum. I'll show you how to do that in the coming weeks. But Axelar is just there for the security side of it to ensure that we have the 75 validators actually backing every cross-chain transaction that was sent. Does it work on Solana? It's top priority right now to get Solana launched. Very close, but it's not live on Solana yet. How much time does it take to take a message to transfer from one chain to another, for example? Yeah, so that's what I was saying before. So it depends on the finality time of the source chain. Base and Arbitrum and other Ethereum layer 2s are slower finality time. Then you have chains like Avalanche and Binance with very fast finality time. So there are other things other than the finality time, but that takes some time. But the finality time of the source chain is by far the biggest caveat when it comes to time. And the reason is not just because we're trolling or anything. It's with security at the forefront at all times. Like we want to make sure the transaction is finalized, or you could suffer from a chain reorg and something's executed on the destination chain that didn't actually happen on the source chain, which is not good for anyone. Show how to edge, please. I'm not sure what you mean by that, Jeff. But if you mean the edge contracts, yeah, that's what we're doing in our future talks. It looks like we're somehow actually right on time. Something that's never happened to me before, so appreciate you guys.
Awesome. Well, thank you so much, Ben, for going over all of that. And as always, if anybody has any... Oh, looks like we got one more here.
Yeah, I'm going to share it right now. I was going to share it next week, but here, let me show it now. It's on our Axelar Scan Block Explorer. I believe it is, yeah, this page. Join the chat. Okay, I'll leave it on our Telegram group. If you go to Axelar Scan and you go to Interchain statistics, if you scroll down, you'll see exactly what you're asking for regarding finality time. But let me. Can you add it in, Austin, to the chat here?
Oh, sorry. Can you say that one more time? I lost your audio. What do you need me to add in?
Just the link. It's not letting me add a link, but it's fine. I'll add it in the note.
Yes, I'll drop that in for you. I'm looking for it. Where did you drop it?
Sending it to you right now on Telegram. Here you go.
Great.
Yeah, so at the bottom of this page, you'll see the times. The big thing you're going to look for is C, which is confirmation time, which is like how long it takes for each chain to get finalized. So the slower ones are typically the L2s. The faster ones are the Alt-L ones, like Avalanche, Binance. Yeah, Phantom. No. Yep.
Okay.
And I'm not sure if the slideshow's still up. Here are some resources that will help. We have, sorry, I forgot to show this before. On the right, we have an examples repository for anyone who wants to get a head start on GMP and seeing, like, playing around with it. On the left, we have a series of helpful YouTube videos, specifically for Solidity-based GMP examples. Yep.
And I'll drop a screenshot of these 2 QR codes into the Telegram group for everybody. You can come back to them easily. Okay, well, wonderful. Thank you so much for going through that, Ben. And I believe, so next week we're going through
GMP, like sending, like sending messages. We'll actually walk through a few code examples together and walk through it step by step. Yeah.
Okay, awesome. And then the week after that, we'll be covering ITS, correct?
Yes, yeah, which is a service that's using GMP to send ERC20s and deploy cross-chain ERC20s. Yeah, it's really cool.
Okay, awesome. Well, thank you so much. And I guess we'll see everybody at those next 2 workshops so we can continue the series. In the meantime, like I said, I'll drop those 2 QR codes into the group chat so everybody can follow those easily. And other than that, we will see everybody in the chat.
Thanks, everyone. Have a good one.
Bye, everyone.